This is really more of a talk probably for your friends than you, because you probably already know this. But the general thing is we want to do correlation across calls, right? So if I have multiple systems, well, the general idea is I want to know that something that happened in a front system made it all the way to the back somewhere. Or if it didn't make it there, where did it stop, right? Like I worked in a system, we actually had 200 machines purchased at one time before the cloud to put this distributed system out there. And they built the demo, and then we just realized we had no idea what was happening. Like we didn't know where the messages went. We didn't know when they stopped. They were doing multi-hop. They were doing fan out and fan in. So, our general idea is we're going to have non-functional requirements that say you should be able to know which messages were actually processed all the way to completion, which ones failed, where did they fail, how many messages were sitting in each spot, right? And there are some frameworks that are good for that, but really what it comes down to in a lot of ways is we want to be able to trace, and the easier kind of one might be like inside a service, the red circles, a call comes in, we do some work, we save some data to the database, and we make a call out, right? That everything that happened inside of that API, you should be able to figure out some way to come with session IDs or trace IDs, correlation IDs, get them injected everywhere. We'll talk about where we get those injected in a minute. And then the harder part is, have I got some standard for getting IDs or some kind of identifiers, which are IDs, as I go across calls? So if I did a multi-hop, how do I track that? And a lot of times you do it really horribly. You're like, oh, I got an ID that goes from producer to the first API, so I can check and see if it got there, and the logs and that might say it. And then that thing makes a call out to the next one. It's got a new identifier, and then you got to know these two identifiers were in the same process. You got to join them all together, or you can have sets of identifiers. But the thing I really want to point out is you have to be proactive about this. It's not like after the fact when you've lost a bunch of data, you're going to be, I wonder where that went. I wonder how many got blocked. Or even if you can configure it out, you burn people out doing it. And so the question is, should we look at this? And are there ways? So we need to manage the IDs, create the IDs, figure out where we need them, add extra places where they may be injected, right? So the out of the box, now there are other out of the box tools, but the basic out of the box tools, unless you've stepped up a little bit in your what your configurations look like, are really logs and metrics, right? And so the service that you build, can generate a log, and there might be aspect-y kind of things on the front of it. And if IDs or headers came in, the headers will end up in the logs. And then and then the platform itself will generate, some logs. But basically, it comes out to relatively general logs and metrics. And some of those can be great, right? Inside a process, all the logs are correlated because they all got the same IDs. And those can end up in your observability platforms, and you'll have a logs analytics platform, and you'll end up with a metrics platform. And sometimes they're the same thing. A lot of people use like Splunk as their metrics platform because they don't generate tracing. They just generate log output, and the log output can be correlated. Whereas if you do like an open tracing, open telemetry thing, you actually get, certain kinds of metrics are automatically generated. They're statistical. The metrics, though, in general, are not tied back to an individual. So if you're using this for balance and controls, did everything get from one place to another? Where did they fall out? Metrics don't give you that. Metrics tend to be statistical. You could end up with some APM tool. They'll tend to do stack traces and other kinds of things. And they will also track identifiers across calls. But basically the idea, you stand up a basic app, you get logs, and you get metrics. And the reason there's two of them here, I just really wanted to show that if you were doing streaming or eventing and you're doing API, really the needs are the same. Sure, one of them's async and one's synchronous, but the reality is they both take data, they both process operation, they both generate logs, they both generate metrics, and then they may either reply synchronously, reply asynchronously, or not reply at all. And so I just want to point out, so for the purposes of the rest of this, any kind of async processing and any kind of synchronous API are really the same thing. So if we need more than that, right, what we need to do, we can generate tracing. But what tracing tends not to do, logs and metrics and tracing, if they're done right, have no PII in them. And they're just very general. So what I found is we want to add the tracing scope to other places. So let me go on the right side first. So I put data in the database. Everybody's used to the idea of last modified by last modified date. But it doesn't tell you last modified transaction, right? It doesn't tell you last modified correlation ID. So I would argue that on the right-hand side, in your database, you should be adding trace identifiers next to the last update. So it'll be last updated date, last updated by, last updated correlation ID, last updated session ID, those kinds of things. If you have correlation IDs, put them in the database. You put the person in the data in there. Why not just put more in there? It doesn't make any sense. And then, it'll be a little different if you have some batchy patch thing, but otherwise, just make it where your data, you can tell where it came from. That's Lineage. The other is, you'll see people will capture basically the event stream that was ingested, or they'll capture the payload of a update, right, in a synchronous API. And I would argue we just write those out, right, because they come in with the metadata for the team that calls, or a request ID is generated in a lot of frameworks. And what I would say is we write that request ID out with the data that came in, and you put that in an analytical somewhere where you can look at it, you could replay it, you can do other stuff. So what should end up happening after this is we should have all of the, and remember, these are for individual changes. It's not metrics. What we should end up with is a correlation or tieback ID for any of the requests that come in that will have logs with that in it. And then any data that is stored or modified as a result of that transaction, we should just append the same IDs to, right? And that would give us adding tracing scope, right? Adding correlating IDs at the front and the back, although sometimes saving data is in the middle. But anywhere we save data would give us the ability to scope work. And if we have history and like a record keeps getting updated, so, if a record keeps getting updated, you're going to lose the correlation ID, right? But if we keep history on those records, or we stream the changes CDC for those records, we could change those correlations, see those correlation IDs change. The only other thing I'm probably pointing out here is replay and analytical. So a lot of times if we have events in the front that are captured, we might use those for replay, especially if they were messages. But I would just put this in the analytical store and not, you can put it in an operational store, but you're not going to, the data metadata is going to go in the operational store. That's the first one here. But basically, for doing any type of tieback, any type of query, any type of triage, we're going to drop all that in an analytical store. So before we were talking sort of like inside the scope, and now the question is, we're actually going to have some event ID, even if we didn't get one on the way in, we created one for all the work we did inside the platform, we tied it to the upsert, or modification events. We tied it to the data modification, went in the database itself. A lot of times we do inter-domain notifications. These would be messages. What we need to do is make sure we apply some identifier to the headers or wherever, the metadata on that message, so that our logs will have an ID in them that can be referenced in the other team's log that will get notified. And this works for outbound message API calls also. I drew it as messaging here. I don't know why. But the basic idea is if we generate inter-domain messages to tell other teams what's happening, whether they're APIs or if they're events, we are going to tag those with the same identifier that we used internally. So that says, hey, we got a call on the inside, on the front. We have an identifier for it. We have the event bound to that identifier, or usually it's more than one. It'll flow through the app into the logs. We'll do a save with the same identifier so we know which event caused which version of this to be updated. And then the inter-domain notifications will carry versions of that ID, and that lets the other team take that in on their input, and they can log or somehow capture the fact that you gave them these span or trace IDs, and that'll link work in our process against work on the ingestion. We'll be like, have you seen message key 5976? And they'll be like, no, we don't have that. That's way better than, hey, we sent you a message with Bob in it. Can you look? Because there might be 10 messages with Bob, and then we don't know which one we're talking about. So like I said, I think what you do is anywhere you've got a feed, basically anywhere you've created a new feed that you might want to put that data in the analytical store, you tag it with the same event ID that you got on the inbound side or that you created. If we're looking at our internal observability context, this is inside our application. Basically, what we want to know is anything that entered, all the activity in it, and when something left, we want to have some way to hang all the stuff we captured inside our context on what went out on the outbound side. You can expand this, and this is really what a large company did. I saw a talk, an AWS talk by a company, and they had like a couple hundred systems they were trying to backfill trace IDs into because they were so complicated. They didn't know why customers' transactions just vanished, right? They just dropped on the ground somewhere sometimes or froze, and people didn't know why. And they couldn't tell, that no balancer controls to know that the stuff had actually flowed through. Talk with other teams, see if there's a company standard for the purple part up above. That's the cross-team context. And then if you look at the red context, that's everything inside our app. There is zero excuse for not knowing what came in, being able to bind that to the logs, binding that to the database, which to me is like the most obvious one a lot of people don't do. And then anytime we're going to do inter-domain messaging or outbound API calls, we put our internal context on it. And then all of those context-bound items of any type should go into the analytical store where we can do triage, fraud, alerting, whatever else. We should look and see if our team can do internal correlation across our different metrics and observability platforms and different components. And then we also need to look at some kind of standard for any kind of message or API so that we get and send IDs that let us stitch a story together. Otherwise, we're making up stories in the outage call. There are other examples out there, or are examples out there, and I didn't bring any into this talk. This was more conceptual, and we're at the 10-minute limit. So if you have any feedback or have a sample code that you think is good at showing this, I'm all interested. Put a comment on the page somewhere. Have a great day.